Hey everyone, welcome back to another episode of How to Code with Chinese Man. So today we're going to look at top K frequent elements challenge. And the challenge is, given a non-empty array of integers, return the K most frequent elements. So for example, if you have an array of 1, 1, 1, 2, 2, 3, and 3, if K equals 1, then you want to return 1 because it's the most frequent. If it's 2, then it's the top two most frequent, which is 1 and 2. Or if it's 3, then you return all of it, or 1, 2, and 3. So my thinking when it came to this was I looked at the constraints. It said that you may assume that K is always valid and that K is less than the number of unique elements. So what that means is you're not going to have, for example, an input array of ones and twos, and then it says return the top three most common elements because there's only two items in there. So you kind of don't have to worry about that error checking. Then the second note is that your algorithm's time complexity must be better than O of n log n, where n is the array size. I'm not too worried about this one because in general we try to go for the most efficient solution anyways, but it's something to keep in mind as well. And then it's guaranteed that the answer is unique. In other words, that the set of the top K frequent elements is unique. So what that means is, for example, if you have an array of 1, 1, 1, and 3, 3, 3, and 4, 4, 4, and then you want to return the top two most common items, that's non-unique because since they all occur 3 times, any two of those three would be the two most common that occur. So essentially these constraints just make it a little bit easier for us so we don't have to deal with those edge cases. And you can return the answer in any order. So I thought about doing a sort and then going through it and then discarding the number of occurrences that aren't up to par. That would work if it was only returned the most common item. And the way that would work is if it's sorted, then you can kind of just go through it, keep track of how many repeats there are of each item. And then if there's an item that repeats more, set the new max to that, and then the new, I guess, most occurring item variable to that item as well. So that would be the O of n solution, but unfortunately that only returns the most frequent element. We're looking for the K most frequent elements. So let's think about this some more. And then I came up with a way to, if we look at the counts first, so that way we organize the array instead of just a bunch of different elements inside of it. We look at the counts of each element. So for example, this initial input of 1, 1, 1, 2, 2, 3, 3, if we store those counts as an object, it'll be an object with three properties, 1, 2, and 3, and the value of those would be 3, 2, and 1 respectively. So that gives us the counts, and then we can go through that to find the K most frequent elements. However, when you look at properties of an object, they're not sorted, and therefore the order of those properties, you can't really rely on that. So the question is, how do we get the K most frequent items out of that object? And we do that by converting it into an array of pairs, of key and value pairs, so that way we can sort by the values. And in an array, that order is kept. And then after that, we just look at whether it's this, if it's ascending order, then we look at the last K items. If it's descending order, we look at the first K items. And then we have our result. So let's go over the code a little bit. So first off, what we do here is we get the counts. This is a O of n operation because it goes through the entire array once, and everything within that array, within that loop, is just run one time. So what we do is we look through all the numbers in the array, and for each item, we increment the count of that element by 1. And this little notation here of, in brackets, of counts at num or 0, what that means is that if counts of num is not initialized, we consider that to be 0. So if this counts of num is undefined or null, it'll treat it as it'll ignore that part and it'll take the 0 instead. And the reason we do that is because if it's not initialized, you can't really add 1 to undefined. And then for every next iteration where it is defined, we just add 1 more to that. So this ends up with a array of counts. Object of counts, where the key is the number and the value is the number of times that number is repeated. Here we convert that into that sortable array. So it's a key value pair of I and counts at I for each item in counts. So what that will end up having will be, for example, in this example 1, in the counts object we have key 1 value 3, key 2 value 2, key 3 value 1. Now we have 3 arrays within that array of 1, 3, 2, 2, and 3, 1. And now we use the sort function. And for JavaScript, the sort function takes a callback that we can define. If we don't pass a callback, it'll use default search, which I believe works for numeric numbers fairly intuitively, but for everything else, the results may vary. But in this case, we pass in our own callback function called sort by. And what that does is sorts by descending order. The way that the callback function is interpreted is if it'll sort it based on the return value of being negative, 0, or 1 in order to determine what gets placed before or after each element. And here we sort it by the value of the key value pairs. Notice that, so here B at 1, remember how I said that key value pair in the sortable array is 1, 3, 2, 2, and 3, 1. So when we look at this, given an item, we look at the count instead of just the element. So this tells us whether the count is higher or lower than the other element that's comparing to. So essentially this block of code will just turn it into an array of array pairs, and then it'll sort those array pairs based on the count in descending order. And then finally we create the results. So what this does is it'll just create that final result array with just the number that we're adding in. So that's the sortable at I, and we take the 0 because remember it's a key value pair. So this will take the number instead of the count. So let me just uncomment out these console logs, and we can kind of see like from the example what it's doing. So here we'll just console log result as well, and then we'll just run through that example. The example is, I believe, that example 1 that's currently there. And notice here, so that counts object turns that 1, 1, 1, 2, 2, and 3 into object of the keys being the element and the value being the number of times it occurs. So 1, 3, 2, 2, 3, 1. Then we convert that into the array. So we have that essentially just converts that first line into that second line format. So I have 1, 3, 2, 2, and 3, 1. Then that gets sorted on line 24. And then notice here we have the descending order of 1, 2, and 3 because it's looking at the counts. So 3, 2, 1, that's descending order. And then finally we just put in the top k elements. In this case the input is 2, so we just do 1 and 2. And there we have it. So this was a bit of an interesting scenario. The time complexity here is O of n log n, and the reason for that is the first run through to get the count object is O of n. The putting it into an array of pairs, that's O of n. The sort is n log n. And then the final one is O of n. So when you do O of n plus O of n plus O of n log n plus O of n, you just get O of n log n. And there we have it, folks. So if you like the video, make sure you subscribe, give it a like, maybe a share, and feel free to comments to Volunteer questions that you have, and I'll try to answer them as much as possible. So this is Chinese Man signing off, and hope to see you soon in another video.